I'm Anil Kumar sharing with you a practice test paper on permutations and organized counting. We have about 20 questions here, right? So we are working on 20 questions. And the time should be around 40 minutes. Since I'll be explaining, I may take around 40 minutes, but when you solve these questions, you should be in a position to complete this test in half an hour. We'll cover the topics organized counting, fundamentals of counting principles, permutations and factorials, principle of inclusion and exclusion, permutations with some identical items. So let's begin. The very first question here is to express as a single factorial form. So we have two questions here. Part A and B is n squared plus 27n plus 182 times n plus 11 times n plus 12. You could actually write this as this quadratic function. We are looking for a product of 182, sum of 27, and that gives you a hint, 11 and 12. You can try 13 and 14. 13 plus 14 is 27. That works. So we could write this as n plus 14 times n plus 13. And we already have n plus 12 times n plus 11. And this could be written as n plus 14 factorial divided by what? Since we are going up to 11, so we should have n plus 10 factorial in the denominator, right? So that becomes the factorial form of the given expression. Now I'd like you to write this in permutation form. Is that clear? So try to write this factorial form into permutation form, that is NPR form, right? So let this be the exercise for you. The next question here is 45 times 3 times 2 times 40 times 80 times 6 times 77 divided by all that. Now here we could actually factor 45 and write this as 9 times 5. We have times 3 times 2. 40 could be written as 4 times 10, right? 4 times 10. Then we have 8 times 6 times 77 could be written as 7 times 11, right? Divided by 21 is 7 times 3, and we already have 5 times 4 times 2 times 6. So as you can see from here, we could actually write this as we have 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 in the numerator, which is 11 factorial, and the denominator here is 7, 3, 5, 6, 4, 2, which is 7 factorial. So that is how you could write this in factorial form. Again, I'd like you to write this in NPR form, correct? So I'm leaving that for you. Next question here is, in how many ways can you roll a sum of 7 or sum of 11 with a pair of dice? So in such questions, we should actually make a grid, a matrix kind of a thing, and then figure out the answer. So what we can do is we can just draw a matrix 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, correct? We are adding and throwing 2 dice. That means the operation here is add, and you could get numbers 1, 2, 3, 4, 5, 6 with 1 dice, and also these numbers with the other one, correct? When you add, what do you get? 1 plus 1 is 2, and then 3, 4, 5, 6, 7. Adding 2's, we get 4, 5, 6, 7, 8, 9. Adding 3's, 3 plus 1 is 4. 5, 6, 7, 8, 9. I made a mistake here. I'm sorry. 2 plus 1 is 3. Then we have 4, 5, 6, 7, and 8. Adding 4, 4 plus 1 I have to do, which is 5, 6, 7, 8, 9, 10. 5 plus 1 is 6, 7, 8, 9, 10, 11. 6 plus 1 is 7, 6 plus 2 is 8, 9, 10, 11, and 12. Now we are looking for combination of sum of 7 and 11. Now sum of 7 you get like this. So many are sum of 7. As far as sum of 11 is concerned, we have 2 of them. Now they are mutually exclusive, right? They are mutually exclusive, correct? So the total number of outcomes is addition of both. So we have 1, 2, 3, 4, 5, 6, 7. So as far as 7s are concerned, that is 7. As far as 11s are concerned, they are 2. So the total is 9. The next question here is, if you have a standard deck of 52 cards, in how many different ways can you deal out 5 red cards, 4 kings, or 3 aces, right? Since there are 52 deck cards, it is 52 and 5 red cards. So out of 52, you have to deal 5 red cards. But see, how many red cards are there? That is what you have to remember. How many red cards are there? So actually there are 26 red cards, right? So you could only get 5 red cards out of the 26 red cards, correct? So the number of combination is 26 P5, correct? As far as 4 kings are concerned, there are only 4 kings in a pack of cards. So there are 4P4 ways of dealing them, right? So all kings are distinct. We have spades, hearts, diamonds, and clubs. 3 aces. So you have to deal 3 aces. In that case, there are 4 aces in all. So 4 aces, and we have to get 3. So these are the total number of ways. You can always take the calculator, figure out the result. 12 shift. Now that is P5, gives you the answer as 7893600. 4P4 is 4P4, which is 24, and 4P3 gives you 24, right? So these are different ways in which you could get 4 kings or 3 aces. Here is a very interesting question on cards. The question is, 3 players select a card from a standard deck of 52 cards. In how many ways could the cards all be face cards or red cards? So let us first understand what are face cards and what are red cards, right? So let me underline these words, face cards or red cards. Now these are called the face cards, king, queen, and jack. Red cards are hearts or diamonds. Is that okay? So that is what it is. Now let's try to understand the question and answer it. So in a deck of cards, we have how many face cards? Face cards means we're talking about jack, queen, and king. And then we have 4 suits, right? So 4 different suits, which are diamonds, hearts, and spades, correct? So which are spades, and let me just make this okay. And then we have hearts, which is red. So let me make them with red. Let me make diamonds also with red. And then we have clubs. So we have in all 12 face cards, correct? Jack, king, queen with these different suits. How about red cards? Now red cards are 26 in number, which are basically diamonds and hearts, right? So which are basically hearts and diamonds. So that is the combination. We are distributing 3 cards and looking forward for face cards and red cards. Clearly what you see here is something common, right? So that means we have to apply the principle of inclusion and exclusion, right? So that means we have a set of cards which could be included twice. So in this particular case, how many are the cards which are of red face card, right? So we can say we have face cards here, we have red cards here, and this is common, which is red face cards. Now red face cards are of 2 suits which are hearts and diamonds and 3 of these. So they are 3 times 2, 6 in number, right? Total we have 12 face cards, that means 6 here, and red cards are 26, that means 20. If you take these numbers, then it is okay. But normally, what do? We find the combinations of 12 face cards distributing 3 at a time. That means we have 12 P3 plus 26 red cards distributing 3 gives us 26 P3. But we have to exclude the ones which have been twice counted twice. These 6 P3. You get an idea. So that is your answer. So it is principle of inclusion and exclusion. So 12 P3, which is equal to 1320, plus 26 P3, which is 15600, take away 6 P3, which is 120, right? Now we can combine these and then get the answer. So 15600 plus 1320, take away 120, gives you 16800. So that becomes the total number of ways in which we could get face cards or red cards, right? Now let's move on and take up the next question. In how many ways can 10 questions be arranged if most difficult and easiest question are side by side? Part B is most difficult and easiest questions are not side by side. And then we have first question is the easiest and the last question is the most difficult. Now in this question, let us first find how many ways can 10 questions be arranged, right? Let that be the first part. So if we have 10 questions, total number of ways in arranging all 10 questions will be 10p10. Is it okay? Or 10 factorial, I should say actually, which is 10 factorial, right? So that is total number of ways in which 10 questions can be arranged. So that is total number of ways. Now here we have one condition, which is most difficult and easiest question are side by side. So that really means that we club them together. So we have total number of 10 questions. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then let's say that is the 10th one. But what we actually do is most difficult and easiest is clubbed as 1. Is it okay? So these two will be like counted as 1. So we have how many options? We have now 9 options. 1, 2, 3, 4, 5, 6, 7, 8, 9. You get the idea, right? So we have 9 options and these 9 can be placed anywhere. So in all, we have 9 factorial ways. Now as far as these two questions are concerned, they could either the most difficult question could come first or the easier one. So there are 2 more ways. So 9 times 2, is the total number of ways. Is it okay? So that becomes the answer for part A. Now part B is most difficult and easiest question are side by side. That's what I answered, right? Most difficult and easiest. Okay, so that has been retyped. I think the first part was when there is no condition, right? So that was the first part. Okay, which is 10 factorial. Anyway, let's move on. So that is repetition. See, first question is the easiest and the last one is most difficult. Now in this particular case, we have fixed first and the last, correct? So in 10 questions, we only have 8 in between. So 1, 2, 3, 4, 5, 6, 7, 8. And therefore, the answer here is 8 factorial, correct? So now we can write down these answers. 8 factorial is equal to 4320. And the first one is 9 factorial times 2, which is 725760. Right? So I think there is a misprint here, but anyway, you can understand. If there are 10 questions with no condition, it will be 10 factorial. This part could be most difficult and easiest questions are not side by side. Oh, I'm sorry. It is not side by side. I'm sorry. Okay, not side by side means we'll take away this number from 10 factorial, correct? So it is 10 factorial, take away this number, which is 9 factorial times 2. So let's find this out. Okay. Good, I read it again. So it is 10 factorial, take away 9. Let me write down this number itself, which is 725760. So we get a very big number, which is 2903040, correct? So that is what we get. Okay. So this is when they are not placed side by side. So you have to figure out all combinations, take away the first one. So I hope that makes sense. Let's move on. Here is the next question. A coin is tossed 6 times. In how many different orders could 7 heads and 2 tails occur? Now this is very tough question for permutation and combination. Actually, if you see, we have 6 positions, 3, 4, 5, 6. We want 4 heads and 2 tails. So 4 heads could be in any position, right? So it could be like 1, 2, 3, 4 heads. And we could have 2 tails in any position. Now, if you're looking at positions, permutations, then you could treat this as items being repeated, right? So we have identical items. Is that okay? So if there are identical items, we're talking about 4 heads and 2 tails out of 6 items, then how can we do it? Well, if this was a case of combination, then we could have done straight away 4 heads out of 6, correct? So the answer could have been 6C4. That will give you the answer, correct? Now we are talking about permutations. So in this case, out of 6, we could position these heads any 4 positions. Do you understand? Any 4 positions. So we get 6P4. Now since heads are identical items, we'll divide this by 4 factorial. Now times, there are 2 tails. Only 2 positions are left once you fix the heads. Therefore, we have 2P2, and since both 2 tails are identical items, we'll divide this by 2 factorial. And that is how we are going to get this solution. So let's figure this out. So we have 6P4, which is 360, divided by 4 factorial, which is, well, we could use 4 factorial, times 2P2. So we have 2P2, which is 2, divided by 2 factorial. So let's figure this out. 360 divided by 4 factorial equals to 15, right? 2 over 2 is 1, so we get 15. Well, in the next unit, we'll learn about combinations. Let's try this answer also. So we'll get 6 combination 4, which is equals to 15. Do you see that? You get the same answer. Since the order is not important here, combination is the correct way of doing it, right? But you could also solve this question using permutations as we did just now. Now let's look into the next example, which is, in how many ways can 5 girls and 5 boys in a choir stand in a line if boys and girls must alternate? Okay, so that means, let's say we have position like boy, girl, boy, girl, boy, girl, boy, girl. So 1, 2, 3, 4, 5 sets. So that is what we want. So there are different boys and different girls. This is important to understand. So the combination for boys are how many? 5 factorial, right? So 5 factorial is the number of ways in which boys can be arranged, times girls could be arranged in 5 factorial ways. But you could have girls first, correct? You could have a combination in which the girls may come first, right? So that is to say that I could write this as girl boy, girl boy, girl boy, girl boy, and girl boy, correct? So that means times 2. So that becomes the answer for this particular part. So let's figure this out. So we have 5 factorial times 5 factorial times 2 equals to 28,800. So the answer is 28,800. Now second part is kind of similar to this with some difference. It says, in how many ways can 6 girls and 5 boys in a choir stand in a line if boys and girls must alternate? So conditions are similar, but in the second case we have 6 girls. Since we have 6 girls, there is only one way girls have to begin the queue, right? So it is girl, boy, and so on, correct? Ending with girl, since there are 6 girls. So in this particular case, the answer will be 6 factorial times 5 factorial. Perfect? Which is 6 factorial times 5 factorial equals to 86400. So I hope the concept is clear. Now these questions are very important from test point of view. I've seen one of these coming up in test. In how many ways can a student answer 5 multiple choice questions with 3 options each if he is sure that the answer for the last one is option A? So basically we have 5 questions and the student knows that for the last one A is the answer, but for these 4 he's just making a choice. So it could be 1 out of 3. So there are 3 possible ways in which those 4 questions can be answered, correct? And therefore the solution will be 3 to the power of 4 times 1, right? So that becomes the answer, which is 81, correct? So that is how you could answer this question. The next question is, in how many ways could you arrange 7 people for a picture if there is no restriction? Peter and Sam must be together. Peter and Sam must not be together. And the last condition is, the eldest person lines up on the left side and the youngest on the right side. If there are no restrictions, there are 7 people, so it is 7 factorial. Perfect. So that is the answer, or you can write 7p7. So that becomes the answer for the first case, so which is 7 factorial equals to 5040 ways. The next one is, Peter and Sam must be together. So we'll club them, right? So we'll club Peter and Sam. So that is clubbed together. And so 7 to have been clubbed. So we are total we have 6, right? 1, 2, 3, 4, 5, 6, 7. In all, since they have been clubbed, we have 1, 2, 3, 4, 5, 6 positions, correct? So it could be 6 factorial. Now Peter and Sam could alternate. One could come first, the other one could be second. Times 2 is our solution, correct? So that is 6 factorial times 2, and the answer is 1440, correct? Next part is Peter and Sam must not be together. That means difference of these two. So it is 5040, take away 1440, correct? So let's do that. 5040, take away 1440. That gives you 3600 as the answer. The last part here is the eldest person lines up on the left side, so left side has been blocked, and the youngest on the right side. So out of 7, we only have 5 in between, correct? And therefore the answer is 5 factorial. So what we get here is 5 factorial equals to 120 ways. So that is how you could answer this question. Now we have another question which is related to similar lines. A photographer lines up 10 students. If 3 friends want to be together, then how many possible arrangements can be made? So this time we have 10 students. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 1, 10. 3 friends want to be together, so we'll just club them, right? So we'll club 3 of them. How many are left for total becomes? Clubbing them together. 1, 2, 3, 4, 5, 6, 7, 8. And therefore, there are 8 factorial ways of arranging them. But within this group, 3 factorial ways of their own arrangement. So the total will be 8 factorial times 3 factorial. So we have 8 factorial times 3 factorial, and the answer is 241920, correct? So I'm speeding up now, just saving some time. These are straightforward questions, as you can understand. Now let's take the other one. A student council has 10 members. 5 are from grade 12, 3 from grade 11, and the other 2 are grade 10 and grade 9. So what we have here is grade 12, grade 11, grade 10 and 9. We have 5 from grade 12, 3 from grade 11, and other 2, that means 1 each from 10 and 9. In how many ways can secretary, treasurer, and fundraiser, that means we are looking for 3 posts, be elected? There is no restriction. So 3 posts, and in all, how many are there? Let's count. It is 10. In all, there are 10. And therefore, with no restrictions, the answer is 10p and 3 positions, correct? So that becomes the answer for the first one. So we can say 10p 3, and that is 720. The second condition here is if at least one is a grade 12 student. Now when I say at least one is grade 12 student, let's consider that not even a single one is a grade 12 student, okay? So we'll do this with indirect method. So we'll say none. We'll say none from grade 12. Let's figure this out. That means we are selecting all 3 from this category, which is 3 plus 1 plus 1, 5. So from 5, we are selecting 3, so it becomes 5p3. Now it says if at least one is a grade 12 student, at least one. There could be more also, correct? This is none, and therefore our answer will be 10p3, which is total number of combinations. I should say permutations. Take away if all are from other grades, not from 12, which is 5p3, and that should give us the answer, correct? So let's figure this out. So it is 10p3 3, take away 5p3, 5p3, and that gives us 660 as our answer, correct? So that is how you could do it. You could do it separately also. You find 5p3, which is 60, take away 60 from 720 and get the same answer. So with calculator, actually, you can do all these operations together. Part C is, if there must be only one student from grade 12, only one student from grade 12. Now this is extremely important part. So we have three different positions. Do you see that? We have three different positions. If there must be only one student from grade 12, then how are you going to do it? Now if there is only one student from grade 12, we can say, let this be the student from grade 12. So we are selecting 1 out of 5, correct? So let me write this as 5p1. And these two positions we have selected from others. So we are selecting out of these 5, 2 positions. So we'll get this as 5p2. You get the idea? However, we could choose grade 12 student not for just secretary, it could be treasurer or a fundraiser. So we are going to multiply this by 3. So I hope you understand why we have multiplied this by 3, and then we get our answer, correct? So that is the solution for only one student from grade 12. So we get 5p1 times 5p2 times 3. So that gives us 300 as our answer. So there are 300 ways in which we can elect or select secretary, treasurer and fundraising chair with only one student from grade 12. So I hope that concept is clear. Okay. Next question here is, how many different ways can 6 people be seated in a round table? Now when we talk about round table, we have 6 people here. It is very important to understand that we have to fix one position, right? So if we have 6 people, 1, 2, 3, 4, 5, 6, then to arrange, if we just move all of them, then they have relatively the same position. And therefore, it becomes very important to fix one position. And then others can move around, giving us new combinations. Is that okay? And therefore, in this case, total number of ways will be, how many different ways can 6 people be seated at a round table? 1 is fixed. So 5 are left to move around. So 5 factorial is the answer, which is 5 factorial equals to 120. So there are 120 ways in which 6 people be seated at a round table. So whenever you're working with round table, fix a person and then find all different ways. The next question here is, a coding system is designed for data transfer. To make errors easier to detect, each code must have no repeated digits. Now that's a condition which we have to follow. Each code must have no repeated digits. Now 3 parts to this question is, part 1, how many 10-digit codes can be created? Now 10-digit codes, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now whenever you start with 10-digit code, in the first position, you cannot put 0, right? So let us assume that 0 is not the first number. So since it will not form a number, it will give you a 9-digit code, right? So here we have only 9 options. Since we have taken up 1 and that cannot be repeated, we have 9 out of 10 left, and then we have 8, 7, 6, 5, 4, 321, correct? So that gives us 9 times 9 factorial as our answer. So it is, let's find out 9 factorial first, and then we'll multiply this by 9, and the answer is 326, 59, 20. Second part is, how many 10-digit codes can be created if the first 3 digits must be 1, 3 or 5? So that means first 3 digits are only from this category of 1, 3 or 5. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We'll club the first 3 numbers together. So we're left with 1, 2, 3, 4, 5, 6, 7, right? So that gives us 7 factorial ways. I mean, this is also there. First 3 is fixed, right? So we have 7 factorial ways. They have to come right in the very beginning. But these could be arranged in themselves. So that could be 3 factorial. So that is the answer, correct? So we have 3 factorial times 7 factorial. 3 factorial times 7 factorial equals to 30240. So that becomes your answer for part B. C is, how many 10-digit codes can be created if the code is an even number? So if I'm saying even number, that means what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That means the last digit should be 0, 2, 4, 6, 8 or 10. Is that okay? So what we will do here is, since we know we cannot start with 0, so there is a case when even number 0 could come here or there, right? So what we will do in this case is, we'll find first for odd numbers, right? And we have the total. So from total, we'll take away combinations with odd numbers to get even numbers. Does make sense. So we are going to do like this, correct? So if I'm having a 10-digit code, in that the last digit could be 1, 3, 5, 7 or 9. So there are 5 possible combinations for the last digit. Once you choose one of those, right? So we are left with 5 more to go, right? So there are 5 combinations here. Once you choose one of those, so we have 9 more to go. We have total 10 numbers, right? Out of those 9, 1 is 0, so that cannot come. So we are left with 8. But if you choose 2, then we are left with 8. This will be 7, 6, 5, 4, 3, 2, and 1. So that becomes the total number of combinations, correct? So what we get here is 8 times 8 factorial times 5, correct? So that becomes total number of odd numbers, right? So it is, let's do 8 factorial first. And then we'll multiply this by 8 times 5, which is 161, 2800. And now, to get the even number, I'm going to subtract from the total this number, which is 3265, 920. Take away 161, 2800. Okay, so let's do this. So we have 3265, 920. Take away 161, 2800, which is equals to 165, 3120. So that is the answer for total number of even codes where the digits are not repeated. Now here's the other question. You can pause the video, copy the question, solve it. I'm taking a break and then we'll begin from here. I hope you are enjoying this journey of learning how to solve questions related to permutations and organized counting. The question here is, the junior choir and senior choir are both singing at the concert. the junior choir has 5 songs and the senior choir can sing any 6 songs. In how many different ways can the entire concert be performed if there is no restriction? And part B is junior choir sings 2 selections and the senior choir 3 selections. Assume the junior choir always sings first. So let's do the first one where there is no restriction. So we have junior choir 5 songs and senior choir can sing 6 songs. So 5 songs gives us combination of 5 songs, permutations 5p5, right? Times senior section 6 songs, 6p6. Now either the juniors can sing first or the senior, so we'll multiply this by 2. So that is the answer for part A. Part B is junior choir sings 2 selections and senior 3 selections. Assume junior choir sings first. So we'll not multiply by 2 since we know junior sings first. And they are not singing all of them. Out of 5, 2 selections, right? So that means 5p2 times the senior ones are 3 selections out of 6, so 6p3. So those are the answers for us. Let's calculate. So we have 5 5 times 6p6, which is total times 2. I have to multiply times 2, which is equal to, for the first one, 172,800. For the second one, we have 5p2 times 6p3, 6p3, which gives us 2400 as our answer. Is it okay? So that is how these questions could be answered. Now this is a very important question from test point of view. Try to understand what kind of variations we made in these questions. So it says, how many different 6-digit numbers can be formed using these numbers, right? So there are 3 types of different questions here. We're looking for 6-digit numbers, 1, 2, 3, 4, 5, 6, and we have to consume these digits, right? So when we have digits like this, that means they cannot be repeated. That is understood, right? We can use them once. There are 6 digits in all. So out of 6, we could select any in the beginning. So the combinations which we'll get will be, for the first position, we could select any 6. And then we have 6, 5, 4, 3, 2, 1. 6 factorial is our answer. Now in the second case, as you can see, when we are talking about making 6-digit number, 1, 2, 3, 4, 5, 6, we cannot begin by 0. So we have to begin from any other 5 digits. But once we use one of these, we are left with 5. So we get 5, 4, 3, 2, 1. So the answer for this is 5 times 5 factorial. The last one here is, we have 1, 3, 3, 4, 4, 5. We find there are repetitions, right? So 2 identical 3s and 2 identical 4s. 1, 2, 3, 4, 5, 6. So we could do any combination, of course, which is 6 factorial. But since there are identical items here, 2 for 3 and 2 for 4, we have to divide them by 2 factorial and 2 factorial, correct? So that is how we could answer this. 6 factorial is equal to 720. So the answer for the first one is 720. The second one is 5 factorial times 5, times 5, which is 600. And the last one is, we'll divide 720 by 2 times 2, 4, which is equals to 180, correct? So these are the answers for the given question. So now we are entering into repeated or identical items. In Switzerland, the postal codes consist of 2 letters followed by 4 numbers. So we have 2 letters followed by 4 numbers. How many postal codes are possible if you cannot use Z and the digits cannot be repeated? Okay, so if you're not using Z, then out of 26, we are left with 25. So these combinations are 25 and 24. Now in the next 4, it says that the digits cannot be repeated. So we have 10 digits in all. So it is 10 times 9 times 8 times 7. That becomes your answer. So let's multiply them all to get the answer, which is 25 times 24 times 10 times 9 times 8 times 7 equals 2. And the answer is 3024,000. Correct? So that is how you could answer this question. Now the question is, in how many ways can the letters of the word minimum be arranged if the vowels must be together? Let's look into this. We are looking for minimum. Now, how many are vowels? So A, E, I, O, U. So we have I's and U. So we have 3 vowels. Now total words are 1, 2, 3, 4, 5, 6, 7. 7 total. So remaining are 4 consonants. Condition is, in how many ways can the letters of this word be arranged if the vowels must be together, right? So basically what we will do is, we have 7 positions, M, I, N, I, M, U, M, 7 positions. Will club together these 3 vowels, right? So we'll club together these 3 vowels since they should be together, right? So we say I, and U are clubbed together. The other consonants could take other positions. So in all, we have 5 positions. 1, 2, 3, 4, and one big one, 5 positions. So that gives us 5 factorial ways. Now out of these 5 positions, we have 3 M's. Do you see that? We have 3 M's. So since they are repeated, we'll divide this by 3 factorial, since those will be same kind. Now, these numbers here could figure in 3 factorial ways, but here again we have 2 i's, so that should be divided by 2 factorial. Do you see that? So that is how this should be answered. It's a very important question. So 3 factorial cancels. We are left with 120 divided by 2, which is 120 is 5 factorial divided by 2, and that gives you 60 as your answer, right? So I'd like you to understand how we did this. There are 3 M's, right? Therefore, we divide by 3 factorial. And in this combination of vowels, we have 2 i's. So we divide by 2 factorial. Correct? The next question here is, we are almost at the end now. In how many ways can all the letters of the word Canada be arranged if consonants must always be in the order they occur in the word itself? So let's rewrite the word Canada. Now in this, we are looking for consonants. These 3 are vowels, so we are looking for these 3 words. Their order should be maintained. Do you understand? So let's find the total number of combinations. So total number of ways in which 6 letters can be arranged is 6 factorial. Now out of this there are 3 a's, so we have to divide by 3 factorial. Do you see that? Now you will notice that in these combination, the order for C, N, and D could change. How many orders do we have here for C, N, and D? These are 3 letters, right? So only one order will be C and D. So the total number of combinations should be divided by 3 factorial to get our answer. So only those many ways will have same order for the consonants C, N, and D. Perfect. So that becomes our answer. So it is 6 factorial divided by, so let's do it. 6 factorial, and then we are going to divide by 3 factorial and 3 factorial, which is 36. And we get 20 as our answer. So it is 20 number of ways in which we can arrange all the words of Canada where the order of consonants remains the same. So I hope you enjoyed this journey of preparing for a test on permutations and organized counting. We took wide variety of examples, and I hope that helps you to prepare yourself for excellent result. Feel free to write your suggestions and views. If you like and subscribe to my videos, that'll be great. Thanks for watching and all the best.